Power plants play one of the most crucial roles in our lives of generating electricity that gives us access to the life as we have it today. So let's have a deep dive into these underrated heavy machineries that give us the power that we have today. The first question that might come to our mind is, what are the power plants and why are they so important? To answer this, power plants are industrial facilities generating power and electricity from the primary forms of energy, which are wind, water, thermal, solar, and nuclear. Everything had changed after Benjamin Franklin's discovery of electricity and Edison's invention of the bulb, and slowly, entire humanity was consumed by it, making electricity as essential as water and food. Electricity has to be generated efficiently to conserve resources, as an overuse can cause problems for our future generations. Now, let's have a look at types of power plants. They can be broadly categorized into four types: thermal, wind, solar, and hydro. Let's take a look at some of the examples of solar farms, wind farms, and other power plants. Solar panels spanning over a large amount of area is sufficient to generate a huge amount of electricity in a very passive mode. They consist of large collections of photovoltaic cells and can be used for personal use as well as industrial use. New is one such example, where the entire electricity comes from a solar plant in Malala spanning over 51 acres of land. This has made Diu one of the only islands in India to have its own electricity generation grid coming from a solar power plant. Wind farms are chosen to be installed in open areas away from civilization as to not interfere with energy generation. Ideal wind speeds for a windmill farm to operate is 18 km per hour to 25 km per hour. They are the best form of passive energy as they do not rely on any other form of industry. Next come the fuel plants, which are thermal-based power plants that burn the fossil fuel and project the pressurized gas and heat onto a turbine. The most common residue are carbon dioxide and fly ash. Fly ash is used to help fasten the process of cement generation, and they are usually accompanied with a cement factory. The only drawback of fuel-driven power plants is the Carnot cycle and Carnot efficiency of the fuel that is being used. Also, it gives a very massive carbon footprint. Next is the nuclear plants, which work on the principle of nuclear fission. Fission is breaking down of atoms, and this breakdown is what generates massive form of energy, specifically heat. Fission is done inside a nuclear reactor, and the reactor then projects the heat to a heat turbine, generating electricity. They have carbon footprint similar to that of a renewable source of energy. They are the most efficient source of energy, and they can generate clean energy at a whopping 92.5% efficiency. This is more than double of most of the aforementioned power plants. Now, let's discuss the most important part of a power plant, turbines. Now let's talk about an impulse turbine. This is one of the most commonly used turbines when it comes to any sort of hydroelectric power plant, and its functionality is rather simple. It works best when it is working in conjunction with any sort of pressurized fluid. One such example is of Pelton's wheel. A Pelton wheel is a wheel having a set of blades on its periphery. It consists of a nozzle that ejects fluids at very high speeds. The rotatory part of Pelton wheel then rotates the rotor part of a synchronous generator. The blades, or bucket as they are called, on the periphery are very lightweight material. A synchronous generator is a type of generator having two major parts, a stator and a rotor. This works on Faraday's law of magnetic induction. Let's have a look at short gif of how the synchronous generator works. The magnets A, B, and C are what are creating the magnetic field around the rotating conductor. The magnets are considered to be the stator part of a synchronous generator, whereas the rotating conductor is called the rotor. This rotatory motion is what is causing an induced electromotive force. The particular synchronous generator in this short gif is called a three-phase AC synchronous generator. Now let's have a look at pumped storage power plant, commonly referred to as PSH or PSP plant. It consists of an upper reservoir and a lower reservoir. Water is allowed to flow and a turbine is located in its path that generates electricity. The excess electricity generated is then used to pump the water up, repeating the whole process. They are of two types, open loop and closed loop. Open loop is generally associated with a naturally flowing body, whereas the other one has artificial reservoirs. Let's look at the first stage of pumped storage power plant, also called as the pumping phase. Water is pumped up the reservoir when there is very low energy demand or very excess generation. During night, the stored water in the upper reservoir is used to generate electricity overnight. The next phase is generating phase. To generate electricity, the upper reservoir needs to have a water stored. The stored water is then allowed to flow through the turbine generating electricity. An ideal height for the upper reservoir is approximately 300 meters. The PSPP is usually accompanied with a renewable source of energy such as windmill or solar panel to meet the demands of pumping water. This also makes the most of hydroelectric power, as hydroelectric power is the most efficient source of non-nuclear energy with minimal waste. Clocking at up to 87% of efficiency, the PSH or PSPP is one of the most efficient source of electricity generation. Let's have a look at the benefits of having a PSPP. As discussed earlier, it is one of the most efficient power plant and fetches around 70 to 80% round-trip efficiency when not paired with a renewable source of energy. Using another source of energy to pump water makes it almost as better as a nuclear plant is without the risky nuclear waste. It is self-reliant and does not need much of human interactions. It is a type of integrated renewable power plant. Thank you for your time and have a great day ahead.